So we're going to look at some solving exponential equations. I went over this with you guys last week, but we're going to look at it again, and you'll get more practice on it. So the first thing that you're going to want to look at is this something that I could just guess and check with? So say you had something like this, 4 to the x power equals 64. You could just guess and check this. 4 squared is 16, so it's not 4 squared. And then you could try like 4 cubed, that equals 64. So you see it matches. So right here you could just say that x equals 3. Over here, 2 to the x power equals 32. Well, I know 2 squared is 4, 2 cubed is 8, 2 to the 4th, 16, 2 to the 5th, 32. So I could say that x equals 5. And if you're really good, you could even guess and check with fractional, with negative exponents. So I know that 9 squared equals 81, but the answer is not 2 because it's actually 1 over 9 squared, which equals 9 to the negative second power. So right here, x equals negative 2. Okay, but we're not looking so much at that. We are looking at when you have a fractional answer that you need to approximate by some means. So let's just go ahead and look at this. Sometimes you need to use logarithms to solve for the missing variable. So the strategy, and I showed this to you guys last week, is that you want to take the log of both sides. So you take the log of 3x and you take the log of 18. Once you take the log of a variable and it has an exponent, you can pull that variable out of the exponent and drop it down on level with the logarithms. That's just a property that they have. Then you would want to go through and eliminate the missing variable, and you would want to solve by doing log 18 divided by log of 3. So let's use our calculator to do that. So we need log of 18 divided by log of 3. And it so happens that the answer is 2.6, and I think you should round to the thousandths place. So we'll go ahead and call this 2.361. So right here, x equals 2.631. I think I got that right. Okay, let's try it again on another example. On this one, we've got 4 to the x power equals 19. Let's go ahead and take the log of both sides. Once we do that, the x comes out of the exponent and drops down in front of the log. So x times log of 4 is equal to log of 19. Then we can divide both sides by the log of 4. And we work it out to figure out what the final answer is. So let's do log 19 divided by log of 4. So I can use the same thing as before, just change the numbers. So I think it was log 19 and divided by log okay, if this ever works, log of 4. Okay, so we're going to go ahead and see what the message is. Wow, I'll just try it over again. Okay, so log 19 divided by log 4 equals 1.4999. So we'll go ahead and put that in as our answer. X equals 1.499. Okay? But let's look at a slightly different example where the exponent is more than just a single variable. So we still start with the same strategy. You take the log of both sides, Okay, this still comes out of the expression and drops in the front. Okay, we are still going to isolate by dividing both sides by the log of 5. But here's the fun part. We still have a 6 in front of the x. So we're going to take this whole thing and we're going to divide that by 6 to get the final answer. So we're going to do log 23 divided by log 25, take that result and divide it by 6. So let's go ahead and see what that looks like in the calculator. So we're going to start with parentheses, log 23 divided by log 5, close parentheses. Now I divide that whole result by 6, and it comes out to 0.325. So right here, my answer would be x equals 0.325. And then just one more example to finish this off. Actually, two. Okay, same strategy, take the log of both sides. So take the log of this, take the log of that. So the expression comes out. So x plus 5 goes to the front. Log of 2 equals log 11. Divide both sides by log of 2. By log of 2. Cancels that, and then this result minus 5 gives me x. So let's look at how that goes into the calculator. So we're going to do parentheses log 11 divided by log of 2, close parentheses, and I believe we have to subtract 5. So the answer to that is going to be negative 1.51. So your answer here would be x equals negative 1.51. Something like that. I think I got it right. It's hard to go between screens. Yeah. Actually, negative 1.54. Okay. Let's look at the last part here, and then you'll have independent practice on the back. One last thing to cover, the natural log and e. 4 reasons that originate from calculus and differential equations. There is a special constant, e, that is a lot like pi. It is irrational, and it is used in certain formulas. For the natural log, it is important to know that ln e equals 1. Okay? ln e equals 1. I'm going to leave that blank just to see how many people are actually listening and not just following along. Let's try one example with natural logs. So, you see my expression right here. We can solve this. The first thing I want to do is isolate the natural log. So I'm going to go minus 10 on both sides, leaving me with e to the 3x equals 8. Then I'm going to take the log on both sides. So I take the log of this, take the log of that. Actually, I kind of messed that up. I don't want to take the log. I want to take the natural log. So I'm going to do ln of e and ln of 8. Okay, now this 3x comes out to the front of the expression. So it's 3x times ln of e equals ln 18, but the ln of e is just 1, so my whole answer is 3x equals ln of 8, so I just need to find the ln of 8 and divide it by 3 to get my answer. So let me show you how I would do that on a calculator. So I'm going to do ln of 8 and divide that by 3. Answer, 0.693. Okay, out of all the things I've covered, this is a huge calculus skill. I cannot express how many times in calculus you'll be doing stuff with e of x and natural logs of stuff. It's an extremely common pattern. So if you're interested and excited by those sort of things, just know that that's a really big pre-cal skill. All right. Let me know if you have any questions on the backside. Finish as much as you can for the most possible points.